Good morning, friends, and welcome to another episode. In today's class, we'll be looking at oxidation numbers. I believe we can start. To start, I will be using the following examples. So let me write the atom, calcium. I write the ion, calcium ion 2 plus. I write the complex ion, NO3 minus 1. Then I write the compound HCl. Now, if you are asked to tell the charge of the calcium in this atom, zero, and it is clear the charge of this calcium is zero. Now, the other thing you need to know about this calcium is that the calcium needs it's a free calcium. What do we mean by a calcium in its free state? Calcium in its free state is simply a calcium that stands alone. It doesn't bound or it's not bonded together with other elements or other atoms in the compound. For example, if I write calcium chloride, this calcium chloride contains calcium, but the calcium in this calcium chloride is not in its free state because it is bonded with another atom called chlorine to form the calcium chloride. So note the difference between atoms in their free state, which means atoms that stand alone, they are not bonded to other atoms in a compound or in molecules. So that's what atoms in their free state. And always atoms in their free state have charges of zero. Like in this case of this calcium atom which has charge of zero. The charge of the calcium 2 plus, this is very clear, it's plus 2 because that's the charge. What about this complex ion? It has a charge, it's very clear, it's written there, it's minus 1. Then what about the HCl? The HCl is a molecule or a compound. Usually, the charges of compounds are written as superscript at this top position. So, when you do not see any number there, what it simply means is that that compound or molecule doesn't have a charge. So, in the case of this HCl, it has a charge of zero. It does not have any charge because there's no number written the superscript of this part of the compound. So the charge is zero. Now, all of these charges that we've just looked at, zero charge, positive 2 charge, minus 1 charge, zero charge again, of either atoms, ions, complex ions, molecules, are what we call the oxidation numbers of these items. So oxidation number simply refers to the charge of usually atoms actually and ions. So that's what we are going to look at. We need to know about the oxidation numbers of atoms. Some of the atoms, we're going to look at them. We need to know their oxidation numbers. Now, the reason why oxidation numbers is very, very important because it helps us when it comes to naming of compounds. So, for example, let's say you can have copper. This copper and another copper. This copper, two coppers can be different. One would have oxidation number of 1, the other will have oxidation number of 2. So you differentiate between them using the oxidation numbers, and that's why we need to know about oxidation numbers. So we're going to go through the following items. There are a list of items we're going to look at, and for each of those items, we're looking at the oxidation numbers. So we'll start with free atoms or atoms in their free state. We've already established that anytime you have atoms in their free state, they always have oxidation numbers of zero. So for example, you have sulfur, you have carbon, you have nitrogen, fluorine, chlorine. As so far as these atoms are not bonded with other atoms to form compounds or molecules, it means they are in free state and their oxidation numbers will be zero. Very important to remember this. For every atom, once it stands alone and it is not bonded to any other atom in a compound or in a molecule or even in the complex ion, that atom oxidation number zero. So we are done with atoms in their free state. Let's look at another item. So we're looking at simple ions. Now, this is a simple ion. So Ca 2 plus, Cl minus, potassium plus 1. Then let me add a last one, sulfur minus 2. These are all ions and they are simple ions. These ions have charges. So this has charge 2, this has charge of minus 1, this has charge of plus 2, and this has charge of minus 2. These ions have oxidation numbers and their oxidation numbers are always equals to charge on them. So in the case of calcium, its oxidation number will be positive. For chlorine ion, sorry, its oxidation number will be minus 1. For potassium ion, its oxidation number will be positive 1. For sulfur ion, its oxidation number minus 2. So the takeaway point is this: for all simple ions, their oxidation numbers will always be the charge in them. Simple as that. Let's look at another item. In this item, we will be looking at complex ions. Complex ions are ions that are made up of more than one atoms. So if I write CO3 minus 2, SO4 minus 2, H2PO 4 minus. These are complex ions. They also have charges on them. The charges on these complex ions are usually written. So this is the charge, another charge, another charge. So the charge of the carbonate here is minus 2. The charge of this carbonate sulfate is also minus 2. The charge of this um, phosphate, the type of phosphate, will be minus 1. So it's very important for you to remember that these complex ions also have charges, and their charges are the charges on them. As simple as that. Let's look at compounds. That's the next item. So let's say HCl, H2, SO4, and CO2. They also have charges, and like we've already stated, compounds would have their charges written as superscript on this part. So if you do not see any number written there, what it means is that the charge is zero. And in this case, or in all of these cases, for these compounds, the charges are zero. So charges on this compound are zero. You need to remember that these compounds, because the superscript that I've indicated there. There is no number there. They do not have numbers within there. These have charges of zero. Let's move on to the next item. Group 1 elements. Group 1 element are elements on the far left hand side of the periodic table. And amongst these elements, you would find lithium, find sodium, you find an element like potassium in this group. These elements always have charge of positive 1. Fixed. They always have charge of positive 1. Yes, hydrogen is supposed to be in this group, but hydrogen has a special property. Or if you even observe some periodic table, you realize that for some periodic table, hydrogen will place under group 1, and for some periodic tables, hydrogen will not be placed under group 1. That's why we have taken hydrogen from this group. But remember that all of these elements in group 1, take away hydrogen, will always have oxidation number of positive 1. It is fixed. So let's move on to the next. Group 2 elements. Group 2 elements, for example, we have beryllium, we have magnesium in this group, we have calcium in this group. All of this group always will have oxidation number positive 2. It is, you need to remember that all the time group 2 elements have oxidation numbers positive, fixed, it doesn't change. So let's move on to the next item. We are going to group 3. Group 3 elements, you have boron in this group, you also have aluminium in this group. And these elements always they have oxidation numbers of positive 3. Fixed. It's very important you remember. Let's move on to the next element. Halogens are group 7 elements, and these elements include fluorine, chlorine, bromine, iodine for the first 20 elements. And these elements would always have oxidation numbers -1. This is also fixed, it doesn't change. And you need to remember this as well. For all halogens, their oxidation numbers would always be negative. Let's move on to the next item. Hydrogen. So we are looking at hydrogen in compounds. Remember, we've already stated that this is hydrogen, and this hydrogen is a free hydrogen. It's in free state. For every free state atom, it has oxidation number of 0. And please, that applies to even the groups. So for this group, group 1 element, in free state, they are 0. But in compounds, that's when they have positive 1 charge. You need to remember that. The group 2 elements, once they stand alone, they are free, so they have charge of 0. But once they are mixed up with other atoms to form compounds, then they have charge of positive 2. I need to clarify that. And that also applies to group 3 and the halogens. So let's come to hydrogen again. In free state, hydrogen has charge of 0. But in compounds, hydrogen would usually have charge of positive 1. But this charge sometimes can change. You could have charge of -1. But this -1 charge, you will not use it as somebody studying integrated science. We'll leave the -1 charge for our friends doing elective chemistry. For integrated science, stick to just this one. That's the only oxidation property of hydrogen you need to remember. It has charge of positive 1. And in most cases, that's what we are going to use. Let's move on to the next item. For the next item, oxygen. Oxygen always has oxidation number of -2. the charge of oxygen in most compounds would mostly be -2. And that's what you need to know. Somebody studying integrated science, you need to remember it mostly having oxidation number of -2. Let's move on to the next item. Now, before we're going to look at the algebraic sum rule. But before we look at the algebraic sum rules, it's very important to also remember the following atoms. Atoms like sulfur, zinc, lead, iron, carbon, and the other atoms, but these are the ones you would frequently meet. Remember, in their free state, every atom has oxidation number of 0. But however, when they mix up with other atoms to form compounds, the oxidation number will not be 0. Now, the same applies to these atoms. But for these particular atoms, they are atoms with what we call variable oxidation states. What that means is that they do not have one oxidation state. The oxidation state changes. So at one point, they might have oxidation state of, let's say, 1. At another point, they might have oxidation state of 2. At another point, they might have oxidation state of 3. So for these atoms, they have variable oxidation state. And at least if you do not know, you need to remember sulfur, zinc, lead, iron, carbon. Let me add manganese. I can even add phosphorus to the group. Add phosphorus. Yes, I can add. So I've added sulfur. Yeah, so these are the elements. They have variable oxidation state, and you need to remember them. It's very important you remember. In the next episode, we'll be looking at how to determine the oxidation state of these atoms that have variable oxidation numbers. Let's move on to the algebraic sum rule. So that's the algebraic sum rule. So let's take a molecule such as H2SO4. Now, this H2SO4 has atoms that come together to form it. So in this case, you have 2 hydrogens, sulfur plus 4 oxygens. Now, these individual atoms have their own charges. So we can decide I would add the charges of the individual atom. So for hydrogen, with that charge of 1, +1, we multiply by the 2. Sulfur, we add a charge to the 4 of the hydrogen oxygens. Now when we add these charges together, it can always be equated to the total charge on the atom. The total charge on the molecule is usually written here. So if the total charge on this molecule is here, in this case, the total charge on the molecule is actually 0. So this sum of the charges of the individual atoms can be added together to give you the total charge on the molecule. This is what we call the algebraic sum rule. And it states that the algebraic sum of the oxidation numbers of the individual atoms in this molecule would always be equal to the charge on that molecule. In the next episode, we'll be looking at this rule. It looks a little daunting, but don't worry, when we move on to the next video, you're going to appreciate the purpose of this rule. And I believe that will bring us to the end of today's lesson. We'll meet again in the next episode. Please subscribe to the channel if you've not already done that. And share the video with your friends who are struggling with integrated science. Remember, renew your subscription. And please stay blessed. We'll meet you again. Bye bye for now.